Dear students, so today I'll discuss the problems on corona based its critical disruptive voltage, visible disruptive voltage and power loss. What are these critical disruptive voltage? I told once the process of corona effect takes place, when it exactly takes place, as I told, if the voltage crosses 30 kilovolt per centimeter, or if distance between conductor between less, if it is too less and the diameter of the conductor is less, some factors, so many factors will be there. Atmosphere conditions, temperature rises, frequency, if it may affect, okay, spacing between the conductor. At that time what happens, once corona starts, whatever it crosses that voltage is nothing but critical disruptive voltage. It's a starting, and once starts, we can see that it's a visible, what we can see, it's a visible voltage will be critical disruptive voltage. Once corona happened, there is a power loss will be there. So what is the total power loss? You have to find out. So this formula you have to remember: critical disruptive voltage VD R delta G naught M naught ln of D by R. R is the radius of the conductor and R is equal to capital D by 2. D is the diameter of the conductor, capital D, small d is the spacing between the conductor, and delta is the density, and then M naught is surface irregularity. Smooth conductor, corona effect will be less. For irregular surface of conductor, corona effect will be more. Okay, delta value out of find depending upon its temperature, barometric. Sometimes delta value directly they specify in problem, otherwise barometric pressure and T, temperature T, they specify, you have to find out. Okay, whatever values you will get VD in terms of kilovolt per phase, convert in terms of line. Same thing for critical visible disruptive voltage also. And you have to remember this formula: mv delta G naught R 1 plus 0.3 under root of R delta. Okay, so all these things you have to remember. They specify whatever values you will get in terms of kilovolt per phase and convert in terms of line, and you have to go for total corona power loss. Here two voltages, one is phase voltage and one is with respect to critical disruptive voltage. Okay, and frequency and delta you specify in problem. Otherwise, if you don't specify, you have to find out delta in terms of barometric and temperature. You have to keep that formula, you have to find out. And this is fair condition. Okay, if it is in rainy condition, corona loss will be more, power loss will be more. That time this VD changes from 0.8 to VD changes to normal D to 0.8 VD. It will, okay, with this we'll start problems. See, there is a three-phase line conductor will be there. Its conductor diameter is 2 centimeter. Okay, so conductor diameter is 2, that is capital D, and distance between they are specified, small d is 1 meter. Dielectric strength, that was that G naught, they are specified. Air density is delta. Dielectric strength is what? G naught max. If they specify, you would convert in terms of RMS divided by root 2, and critical disruptive voltage you have to find out in terms of line. Air density delta, irregularity factor is M naught. Okay, so all those that we have solved here, all those values you specify. Critical disruptive voltage formula you write. M naught is there, R is there, you have to find out in terms of diameter. There's capital D, they are specified. Capital D divided by 2 you have to do. Capital D is R is D by 2, and delta they are specified. G naught you have to find out in terms of G naught max, that is divided by root 2 for all, even though if they won't specify. So you have to keep it 30 kilovolt per centimeter divided by root 2 you have to do. You will be getting of this value. For all it is same. Okay, and D by R you have to do. Substitute here, you will be getting critical disruptive voltage at which corona starts, and this is the line voltage. Okay, same, this is the book problem, just compare and do it. This is solved problem as what I have done. Okay, so in this problem, same, but here two voltages you have to specify: critical disruptive voltage and critical visible disruptive voltage. Two voltages you have to find out. Temperature they are specified, at what temperature, and barometric temperature, because here delta they are not specified, you have to find out delta. That's why barometric and temperature they are specified. And then equilateral spacing between the conductor they have given. Okay, D small d, and irregular space factor, irregularity factor they have given M naught 0.10, MV value they have given 0.75. Okay, D you have to find. D is 2.75 centimeter. Diameter of the conductor is how much here? 1.5 centimeter. Small d is 2.5 spacing. So I told G naught, even though if they won't specify, you have to take it 21.2, and how they got 30 by root 2. Substitute the values in terms of critical disruptive voltage. Write down this formula. You will be getting in terms of kilovolt per phase, convert in terms of line. Similarly, you have to do for visible disruptive voltage. Write down the formula, substitute all those values. You will get in terms of phase, convert in terms of line. Okay. So now in this problem, this is important, so many times it has been asked. This is one type of question per problem. All previous also, those two also question mark, but this is regular problem, it has been asked. Here they have specified VD value itself, line voltage exceeds. Actually they have given diameter of the conductor, corona takes place. I told once corona takes place, that corona voltage will be visible disruptive voltage. Corona looks, we can see that is visible disruptive voltage. Okay, and just critical disruptive voltage nothing but VD. Visible is, we can see, just takes place here, that is 210, that is VD value, that is in terms of line, you convert in terms of phase. Okay, and G naught max you have specified, find distance between conductor, small d you have to find. All those values you have to substitute, d you have to find, r you have to find out d by 2, G naught max everything you substitute, m naught value they are given, and delta is 1, even though if they won't specify, so delta and m naught you have to keep it 1. Assume that delta and m naught in this value they are not specified both values, so even though if they won't specify delta and m naught values, you have to keep it 1 and you have to find out d. So many times it has been asked, this is important problem. Okay, and the problem, so here you have to find out corona power loss. What is that formula of corona power loss? Here in terms of frequency is there, and two voltages you will be getting, phase voltage and D. These two voltages you have to find out. Okay, so barometric similar procedure only. So to find out this VD, this formula, critical disruptive voltage, all values are specified in this problem itself, m naught, G naught, T value, B value, diameter, capital R, sorry small r, keep it all those values, get G naught value, even though if they won't specify, you will be getting 21.2 fixed 30 by root 2. Okay, substitute all those, you will be getting VD value, phase value, given value is line here. What is that line? 220 kilovolt. Divided by root 3 you have to do, V phase you will get. So if you do it subtraction, you will be getting power loss. Okay, and total corona loss will be 3 times of what values you will get. In terms of that you have to find. So what they told here, you have to find out here total corona loss. Total corona loss per kilometer of the line. Per kilometer they told actually. This is kilovolt per kilometer per phase. Per kilometer in the sense, again you have to multiply by 3. It will be kilovolt per kilometer. Okay, kilowatt per kilometer phase it will go. Okay, per phase 3. You have to multiply. Okay, so now I'll go for another problem. Here for different fair condition and weather condition they specified you have to find out corona loss. I told if it is rainy situation, VD is changed to 0.8 VD, that is the change, remaining same. Same procedure, previous what you have done, same procedure you follow. First method is same as what you have done previous problem. You will get B value, T value, D, delta, and all those values they are specified, and VD, V phase, P, everything values they are specified, and P you have to find out, and VD you will get, V phase is whatever value they are specified in problem divided by root 3 you have to do. Okay, and once you will get this, what is that extra you have to do here? In terms of atmosphere condition they told, VD changed to 0.8 because in rainy condition critical disruptive voltage changes here obviously. It will be more, corona power loss will be more here. So it will be 57.27 you will be getting VD. Okay, once you will get VD, substitute here, the corona power loss you will be getting in terms of 2.9716 kilowatt per kilometer per phase. Okay, kilowatt per kilometer per phase. Before it was 0.1761 in fair condition. So loss will be less, but here in rainy condition loss will be more obviously. Okay, so next I'll go for what are the, these are all problems. With these problems go through that. First write down the formula and go through all those problems. What are the factors affecting corona here? So it depends upon different factors. One is frequency, that is supply frequency is 50 Hz. Because of corona effects, what happens? Frequency gets disturbed. So frequency will break into different form of frequency, multiples of frequencies takes, that is harmonics it will create, so which will disturb, it may affect efficiency also. Okay, as voltage level goes on increase, obviously corona loss will be more. It affects on atmosphere condition, rainy condition it will be more. Size of the conductor depends, so that's why the conductor size has to be increased here. Okay, so loss will be less. Surface condition, if it will be smooth, corona loss will be less. Rough, it will be more. Number of conductors per phase, bundle conductor has to be used here. Spacing between the conductor has to be maintained, it should be more. Shape of the conductor we have to maintain. For uniform cylindrical shape, corona loss will be less. For flat and oval cylindrical, so obviously more. Clearance from the ground, it should not be less, it should be high. Loss can be reduced. And load current has to be maintained here. If it won't maintain, corona loss will be there obviously. Okay, So if temperature obviously if it increases, what happens? Even though dust whatever above that on the surface, so it won't get deposited. Okay, the temperature current also plays a very important role here. Okay, so that's why if dirt will be there on that, snowfall will be on the conductor, obviously rough surfaces, corona loss will be there. So that's why it has to be reduced. So these are all the effects here. And what are the methods to reduce? I told how to reduce this. You have to increase the conductor size by using bundled conductors. You can reduce by increasing the conductor spacing between the conductor distance spacing has to be increased using hollow or bundled conductors. Obviously, thickness of the conductor will be more, corona loss it will reduce. And what are the effects? Once it has been happened, efficiency it will affect. Okay, it will increase the ozone gas. Conductor sometimes gets corroded. Okay, and nearby radio and television interference also it will affect animals and human beings. Sometimes it may affect on animals and human beings. Okay, but sometimes what happens? They told corona also having some advantages. See, once corona effect takes place, what happens? Even the natural occurring lightning takes place, because of corona effect it will reduce. See, this is one advantage also sometimes you can call. And because of corona, visual diameter of the corona, if it goes on increases, suddenly the corona effect will reduce. Okay, how it means? Whatever air surrounding the conductor gets ionized due to corona. Okay, and the once corona extends its immunization, so that it will spread in air, it will reduce. Okay, sometimes you can call somewhat advantage, but almost not disadvantage will be there. Power loss will be there, harmonics effect will be there, and at last, sometimes conductor gets corroded also. Okay, so that's why corona has to be maintained. So that's why bundle conductors, spacing between the conductors. Okay, so all those as per erection wise, they'll maintain height of the conductor, what height they have to mention, all those things. So which will affect corona. Thank you.